So it has started recording. So today we are looking at moles of gases. So let me just tag it as GCSE level. So what we are looking at is mole of gases. So here we want to look at how to calculate the mole of gases. And when we are done with this, we look at solution. So the mole of gases is what? The volume at STP divided by 24 dm cubed. Why is that 24 dm cubed coming from? You see, the 24 dm cubed is coming from the fact that 1 mole of the gas at STP, STP means standard temperature and pressure, occupies 24 dm cubed. Some book, like some other textbook, you see 22.4 dm cubed. But for this level, we are making use of what? 24 dm cubed. So for easy calculation's sake, are we together?
Yes, sir.
So take note, 1 mole of the gas occupies 24 dm cubed. So if I ask you, 2 mole of the gas will occupy how many? 2 mole of the gas will occupy how many? If 1 mole is 24 dm cubed, then 2 mole will occupy how many?
That'll be 48.
40 exactly. So let's look at this question. First, simple question. They said that okay, let's say, let me write this one. What's the volume? What's the volume of 319.5 gram of chlorine at STP? Simple. They just give you this. What's the mole of this at STP? Solution. You see, don't forget something that, what is the volume? You have to calculate the volume. You see, don't forget something. They ask us to calculate the volume at STP. We don't know. You see, this 319.5 gram is the mass. And can you tell me what's the molar mass of chlorine? You know, chlorine is a diatomic gas, Cl2. So the molar mass will be, and don't forget, the atomic mass of 1 chlorine is 35.5. Are we together? If you check your periodic table, this is what you will see. Okay. So can you hear me? Hello, can you hear me?
Yes, sir.
Okay, good. So for chlorine, that's 2 times 35.5, and that will give me 71 gram per mole. So that's the molar mass. Now, don't forget something, that I gave you this formula. Mole is equals to volume at STP divided by 24 dm cubed. Now, don't forget, what's the formula for mole I gave you the previous class? Whenever you are dealing with mass, what's the formula for mole I gave you in the previous class?
Mass over molar mass.
Exactly, mass over molar mass. So I want to give you like something like almighty formula. So you have something like this. You have something like this: volume at STP divided by 24 dm cubed. So this formula that you are seeing here is sufficient for you to calculate mole of gases, most especially when you are given mass like this. So let's go. What's the mass? 319.5. Molar mass is 71. We've calculated it. Volume at STP we don't know. Divided by 319.5. Sorry, 24 dm cubed. Sorry, that's a mistake. 24 dm cubed divided by 24. So let's cross multiply. What do we have? We have 71 times volume at STP equal 319.5 times 24. To find volume at STP, divide both sides by 71. So punch your calculator. What do you get here?
I'm coming, sir. 319.5 times 24. 7668. That's 108.
108 dm cubed. That's our answer. As simple as that. Do you find it very simple?
Yes, sir.
As simple as just use the formula and you're good to go. Okay. Now, these are straightforward questions that you can see without equation. So without equation, you'll be seeing something like this. I'm coming. Let me still see if I can. Let me still look for some question that you can see without equation. Okay, let me see. Number 2. Okay. Calculate the volume of 3.0 mole of hydrogen gas at room temperature.
Wait,
At room.
Sasawala,
Yes,
what are we
yes.
doing after this one?
What is it?
What are we doing after this one?
Like after we want to look at solution, the one that have to do with concentration.
I don't
Is
think
there
this
any,
one is familiar to me because I don't think we're doing this because it's not really familiar to me.
but just learn it in case. Just
Okay,
this
sir.
after the just learn it. Okay, so calculate the because this is actually GCSE something I'm looking at. Even if you don't do it now, it's to strengthen your understanding and you do it later. So it's just like a
Okay, sir.
plus. So calculate the volume of 3 mole of hydrogen gas at room temperature and pressure. Still the
So I
same
gotta
formula.
ask you what organic chemistry is about because we're doing that one next.
Yes, when you are talking about organic chemistry, you know the word organic, we are talking about plant and animal origin.
Yes.
Yes, exactly. If I tell you that organic acid now, they are acid that if I tell you that their natural source will always be either plant or animal. Let me give you an example. If I say tartaric acid is an organic acid that is from grape. Are we together?
Yes,
Fatty
sir.
acid is an organic acid. It is from what? Fatty acid is from fat and oil, and so on like that. So organic acid major and organic chemistry major, they are talking about the naturally occurring compounds of carbon that exclude, let me say, carbon dioxide, all this one that you know. Let me tell you. You see, the chemistry of carbon that do not involve inorganic compounds. So what you are looking at majorly is compound from plant and animal origin altogether.
Yes, sir.
Is that what you want to look at? So yes. So you first study carbon, you look at alkanes, alkyne, and so on like that.
It's interesting.
Very interesting, but it's one of the toughest. It was tough for us in advanced level because advanced level we stretch it to some point. So let's go. So this is our question. So what do we do? Don't forget, mole is equals to volume at STP divided by 24 dm cubed, right?
Yes, sir.
Good. And don't forget, yeah, they give us mass. Do I have to change this one to mass? Do you know why I changed this one to mass over molar mass? Let me tell you why. Why? Because they gave me mass in this question. Yes or yes?
Yes, sir.
But yeah, they just gave me mole. So I don't have to change this one to mass over mole. I'll just waste my time. They gave me mole already. So what do I do? What is my mole from here?
Your mom is 3.
3, good. Equal to, I don't know the volume. That's what they asked me to calculate. Divided by 24. So cross multiply. What do you have? The volume at STP equal 3 times 24. And what's 3 times 24? Is that
Uh, 3 times 4, 12, 72.
GN cubed? Yes. If they ask you to find your answer in CN cube, what do you do? What do you do?
The
Tell you
what?
that. If they ask you to find your answer in CN cubed, what do you do?
You convert decimeter cube to centimeter cube. 1 centimeter cube. No, 1,000
Okay.
centimeter cube is equals to 1 decimeter cube.
You can just go find your way, and that's it. Wait, in your school, did they teach anything about concentration, mole per dm cube? Did they teach you that?
Yes, yes. They also taught us the conversion stuff too.
Exactly, you can see. So it's exactly part of it. So now let us now look at the one that have to do with equation that you can see chemical equation there. So look at this. They said how many. They said how many. Sorry, how much? How many? How much? Anyhow, how much carbon dioxide is formed? When 30 dm cubed, when 30 dm cube of oxygen reacts with carbon monoxide, and you have this equation.
Okay. Usta.
Are we together? So let's go. So you have this equation, 2CO gas plus O2 gas going to give me 2CO2 gas. Let me interpret this for you. You see what is here? It's telling you something about 2 mole of carbon monoxide reacts with 1 mole of oxygen gas to produce 2 mole of carbon dioxide.
Yes, sir.
Can you say that? 2
Yes,
mole of
sir.
what? 2 mole
2
of what?
mole of carbon dioxide reacts with
Carbon
1 mole of
monoxide. This carbon
oxygen
monoxide. This
to
carbon
produce
monoxide.
monoxide.
Yes.
React with 1 oxygen,
1 mole of oxygen.
1 mole of oxygen to
Mhm.
produce 2 mole of carbon dioxide.
Exactly, that is it. So they said that what? How
So why is
much
carbon monoxide dangerous?
carbon monoxide? Yes, it is dangerous because it attack the hemoglobin in the blood. Remember that the hemoglobin is responsible for carrying out for transmitting oxygen around the body. Remember, it is the pigment that is present in the red blood cell. It is used for what? For carrying oxygen around the body. So carbon monoxide attack hemoglobin. So when it attack hemoglobin, there is no way for oxygen to travel around the body, and that will cause suffocation, and that is death. Do you understand?
Yes, sir.
Exactly. So that is why. So it will combine with hemoglobin to form carboxyhemoglobin, and that compound is very, very stable. It's very, very stable. So it will be eating up the hemoglobin till there's no hemoglobin in the blood again, and that is suffocation, and that is death. So that's why it's very dangerous. Very dangerous. All right.
Yes, sir.
Good. So let's go. How much carbon dioxide is formed when 30 dm cube of oxygen reacts with carbon monoxide? Now check. They are telling you how much of this is formed when 30 of this react. That is it. It's very simple. So in stoichiometry, just know what you are looking for and what you are asked to find. They said how much of this, that you are asked to find this when 30 of this reacts with this. So it's like you are given oxygen and you are asked to find carbon dioxide. Do you get my point?
Yes, sir.
Good. Now check from this stoichiometry. Do you see 1 mole of oxygen? 1 mole of oxygen reacts with what? Reacts with 2 mole of carbon dioxide. Do you see that?
Yes, sir.
Now, if you now check 30 dm cube of oxygen, look at that 30. That 30 dm cube will react to give you what? In fact, let me even tell you something. It is possible for me to do it this way. I can call this one mole, 1 volume. It's possible for me to say it reacts with 2. Since all of them are gases, I can use what they call Gay-Lussac's law to relate this. So 1 volume of this reacts with 2 volume of this. Are we together?
Yes, sir.
So 30 volume of this, that is 30 dm cube of this, it will react to give you what? 30 dm cube we have to give you, like I say, x. Are we together?
That'll
X.
be
X. So
X
x times
times
1,
2.
and that'll give me what?
60.
60 dm cubed of carbon dioxide. That's that. As simple as that. That's how you just be doing it. Okay.
Yes, sir.
So we are done with gases like that. So next one is concentration. So that's solution. That's why you say concentration. Okay. So now let's look at that word concentration. If you say the word concentration, what does it mean?
Concentration is like how dilute this, how many particles is in the solution or something like that.
Okay, there's no problem. You are also correct by saying that you can say, okay, the amount of substance in a given volume of a solution altogether is what we call concentration. Okay. And if I want to say it in a layman language, I can say concentration is a measure of how crowded things are. How what?
I'll
Crowded
put the
things
things
are.
down.
If I increase the number of people in that place where you are, it means that I'm increasing the concentration of people. Do you understand that? That is,
Yes.
let me say, you who are in a given space. If I increase the number of people staying with you there in that same space, I'm saying that I'm increasing your concentration. So if I now relate that to chemistry, I say, well, concentration is the what? Let me write it down. It is the what? The amount. Concentration is the what? The amount. The amount of a substance. Of a substance in a certain volume. In a certain volume. In a certain volume of solution. In a certain volume of a solution. That is it. That is it. Okay, so how do we now calculate concentration? You see, concentration can be calculated in two ways. Look at this first formula. Say concentration. This concentration now, I can calculate it by saying mass of solute divided by volume of solvent. And remember, mass is measured in grams and volume is measured in dm cubed. So this concentration now, if there is a concentration equal to mass over volume, your units will be gram per dm cubed. Now, secondly, if I'm saying concentration equals to mole of solute, altogether,
Yeah.
mole of solute divided by
Thank you.
volume of solvent, this unit to be what? Mole per dm cubed. So we have two formula to calculate mole now. The one in gram per dm cube and the one in mole per dm cube. The one in gram per dm cube, we are saying mass over volume. The one in mole per dm cube, we are saying mole over volume. It's as simple as that. Yeah. All together. So if I
Yes.
want to find number of mole now and I cross multiply, I can say number of mole equal concentration times volume. Let me do what they always do for small children. See, they do something like this. They'll not do something like this for them. They'll not do something like this for them. Then I say mole equal to what? Concentration times volume. Yeah. So if you cross multiply, you will get this. So that's it. So let us solve question. So look at this question. It said that what's the concentration in gram per dm cube of a solution sodium chloride? Sorry, please. What's the concentration in gram per dm cube of a solution of sodium chloride where 30 grams of sodium chloride is dissolved in 0.2 dm cubed of water? Water is the solvent. The meaning of, have you taken Gary before now?
Yes, sir.
When last did you take Gary?
Maybe like during Ramadan.
Okay, good. Let us use Gary and water as an example. Gary here, you know that it is the one that you are dissolving inside the water. So Gary is called a solute. That substance that want to dissolve inside the solvent is called a solute. Why the substance that is dissolving the solute, we call it solvent. If you mix solute and solvent together, you get solution. If you mix solute and solvent together, you get what? Solution. So that's it. So let's go. They say, what's the concentration in gram per dm? You can see they say, what's the concentration in gram per dm? Now, with that statement, which formula do you think you use? Is it equation 1 or equation 2?
Equation 2.
Why? They said, what? Look at the question. What's the concentration in gram per dm cube?
Sorry, my bad. Equation 1.
Equation 1, exactly. Of a solution of sodium chloride, where 30 grams of sodium chloride is dissolved in 0.2 dm cube of water. So we are now saying concentration in gram per dm cube. That's what? Mass over volume. Mass over what? Can
Mass
say
over volume.
mass of solute over volume of solvent. So let's go. What is our mass? What's our mass in the question? Look at it. What's the mass?
Our mass is 30 grams and then
30.
our volume is 0.2.
0.2.
Oh, we have to change it.
So dm cube, no, it's fine. It's fine. They are all, see, it's matching. Dm cube is matching. This one is also matching.
Okay.
Yes. So see what you will do here. Multiply both up and down by 10. That will give me 300 divided by 2. If I multiply this one by 10, you have to. Do you get that?
Yes, sir.
So this will give me 2 here 1. 2 in 30 will give me 15. So my answer is 150. So therefore, my answer is 150 gram per dm cube. Do you see that?
Yes, sir.
Simple as that. Very, very simple. Very, very simple. So next is just for you to be solving.
Now this one is so easy. Unlike limiting reactants.
Yes, yeah, limiting like I told you, limiting reactor is something a little bit advanced, a little bit. But your own are very, very simple. The one we will do are always like they will link it to percentage, they will link it to a lot of things. So now it's simple. That's how we do it. So this is what we now want to do now. Check it out. I'm coming. We want to look at how to convert. Now, converting mole per dm cube to gram per dm cube. Converting mole per dm cube to gram per dm cube. Converting mole per dm cube to gram per dm cube. That's it. So this is what we always do. See, let me tell you, it is very simple. See, look at this formula. Concentration in mole per dm cubed is equals to concentration in gram per dm cubed over molar mass. This is the formula we use. Very, very simple. It's like I'm saying mole equal mass over molar mass. That's it. Now, let's look at this question. Look at this now. I'm coming. All right. Okay. First, let me first give you something. If I say convert 2 mole per dm cube of sodium hydroxide to gram per dm cube, and I gave you this information that sodium is 23, oxygen is 16, and hydrogen equal to 1. How do we actually solve? Did they teach you percentage yield?
Percentage what?
Yield.
View.
Percentage yield.
No.
Okay, good.
That's for the triple science people.
Okay. All right. So this is what we want to do. All right. So let's solve this question. Solution. Before you solve, calculate the molar mass of sodium hydroxide. Oh, yeah, I want you to do this. Calculate molar mass of sodium hydroxide for me. With all these parameters, what do you have?
I guess I should calculate it.
Yes, molar mass of sodium hydroxide. What do you get? What do you get?
Wait, convert 2 mole of nitrogen to gram. Oh, that's easy.
Yep.
Wait, so sir, for every 2 mole is 1 decimeter or
No, I don't ask you to. Okay, do you want to solve all the question? Just calculate the molar mass, don't worry.
oh, you said I should calculate I thought you said I should answer the question.
No, just molar mass.
Oh, that's just 23 plus 16. 9, 3, 40.
Good. 40 what?
40 gram
Gram per mole.
per mole.
Good. So you have this ought to be 40 gram per mole. That's correct. So don't forget that we want to calculate concentration in gram per day. Can you just look at this? Look at this top. How do we calculate concentration in gram per day? We can cross multiply. So if I cross multiply, what do I have? You see that I'll say concentration in gram per day cube equal to what? Concentration in mole per day cube, right?
Yes, sir.
Over what? Molar mass. Sorry, not over molar mass, times molar mass. Times molar mass. So let's go. What is the concentration in mole per day? You look at this. What do we have? Right?
Yeah.
Times what do we have here? Molar mass is what? 40. And that'll give us what? 80 gram per day. Do you see that?
Yeah.
As simple as that. Okay. As you're going down, you'll be saying, okay, you're getting a little bit technical. Just all of them are your level. I'm not giving you something above your level. Okay, look at this one again. Very simple. 0.5 mole of sodium hydroxide, that's that NaOH. Sodium hydroxide is dissolved in 2 dm cubes of water. Full stop. Chocolate the concentration of the sodium hydroxide solution form. That's solution. So form. Well, let me help you add this. In A, mole per dm cubed.
Sir, please can you give me a minute? I want to use toilet.
Okay, gram per dm cubed. Are you back?
I'm back, sir.
Okay, you're welcome. Okay, so let's solve this question. So we all know that molar mass of sodium hydroxide, that is 40 gram per mole. We just calculated it. They said I will calculate the concentration. Look at it in mole per dm3. So remember, concentration in mole per dm3. That is what? Mole of solute divided by volume in dm cubed. So let's go. We have the formula already. We have it up there. Look at it. We have it. Not this one. This one. Mole per dm cubed. So this is what you have. All right. So let's go. Now, what's the mole here? The mole here is what? The mole here is what? 0.5 divided by what's the volume? 2 dm cubed. So 0.5 divided by 2. What do you have? 0.5 divided by 2. Now give me 0.25 mole per dm cube. And don't forget, there's the calculate concentration in gram per dm cube. Don't forget that our concentration in gram per dm cube is equals to concentration in mole per dm cube times molar mass. Times molar mass. So let's go. So this will give me 0.25. This concentration in gram per dm cube, I've gotten it here already. Then times molar mass. What's my molar mass? My molar mass
0.2. Oh, wait.
0.25 times
Oh,
40.
molar mass. Sorry.
0.25 times 40. That will give me 10. That will give me 10 gram per dm cube.
How can you do all this math in your head so fast?
It is very easy. It is very easy. You will have known that 0.25 is 25 over 100. You will see how easy it is. Times this one is what? 40. I know that normally, I know that 25 times 4, I know that is 100. So to make this one 1,000. So 1,000 divided by 10, that's 100. That's also. If we make it 1,000 divided by 100, that's 10. Easy.
I don't know how those people used to do those mental maths. Like, oh,
yeah, there's a training for it. It has training. It has training. It has training.
So did you do the training?
No, I don't. I've not learned how to train people on it. It's
Nobody
not
did it. Can you do it? I know you can do it, but like, did you do the training?
And the thing is that normally I can do it based on my own personal something, but there is actually a training. It is called abacus training. That is a trick from abacus. If you can use abacus very well, there's a way you'll be using abacus. There's a way they will do their finger. Actually, I wanted to try the training, but it's very expensive. About 100,000 plus per month.
Oh.
So, yes. But actually, let me say that I'll go the training to be so fast for me. Then I'll come and teach you and you pay me big money. So let me just give you class work. When you are doing something, and I will download this note and send it, and the video. If it takes some time, they will pop up in my Gmail. I'll download it, edit it, and send it to the YouTube and give you the link. Is that clear?
Okay, sir.
Let me just give you the class work. I'll be exercise.
Oh,
that's Alia's voice. I can hear Alia's voice in the background. Correct? That's Alia's voice. Am I right?
Yeah.
I know. Calculate the concentration of 7.3 gram per dm cube hydrochloric acid. in mole per day. They give you something like this. It means that they have given you the mass already. Check, you see, the molar mass, they are giving you everything already, 36.5. So you don't have to calculate anything again. They are giving you everything here. That's it. That's the two questions. Have you written it? Have you written the question?
No, sir, I'm writing it.
Look, I don't have money.